This video is over the notes section for Objective 4.3. This section is about evaluating functions. In order to evaluate a function, we really need to know what a function is. So there's several different ways to represent functions. Notice at the top of your notes section how it has the equation y equals 5x plus 3. The function notation is f of x equals 5x plus 3. And all that says is that the function name is f and that the input is x. F of x would then be the same as y, or the output. So example 1 says evaluate the following functions given: f of x equals x squared minus 3x, g of x equals 2x minus 1, and h of x equals 4 to the x. A says find f of 3. What that means is plug 3 into function f where you see an x. And so I'm going to go to function f. I'm going to plug in a 3 everywhere I see an x. So I'm going to do 3 squared minus 3 times 3. And then we're just going to use our order of operations. So you guys have already done something really similar to this. So order of operations says to do exponents first. So 3 squared is 9 minus 3 times 3. Now we would do multiplication. So 9 minus 9, because 3 times 3 is 9. Now we're going to do our subtraction, so 0. So f of 3 equals 0. That tells us that when we plug in 3, we get 0. So g of 3 is going to be the same way, but this time it says plug it into g. So everywhere I see an x in g, I'm going to plug in a 3. So order of operations says to do multiplication before subtraction. So 2 times 3 is 6, minus 1 is going to give us 5. So g of 3 equals 5. That tells us if we graphed g of x, the point 3, 5 would be on the graph. H of 3. Everywhere I see an x, I'm plugging in a 3. So we have 4 cubed, which is 64. That tells us that if we graphed this, that the point 3, 64 would be on the graph. Okay, so on D, it says find f of 3 plus g of 3. So f of 3, we already did that. If we hadn't already plugged 3 into f, we would have to redo that. But we already plugged f in here. So then we know that f of 3 is 0. And g of 3, we already found that here, is 5. So this says to do 0 plus 5. So f of 3 plus g of 3 would be 5. On E, find f of negative 2 plus g of negative 1. Well, we haven't found f of negative 2, so we need to find that first. F of negative 2 means plug negative 2 in everywhere we see an x. Notice how I put the parentheses. That's really important when you're squaring a negative. So we get 4, and then negative 3 times negative 2 is positive 6. So f of negative 2 is 10. G of negative 1. 2 times negative 1 is negative 2 minus 1, so negative 3. So g of negative 1 is negative 3. And now it says to add those two numbers together. So 10 plus negative 3 is 7. We're going to do the same thing on f. So it says find f of, or it's find h of 2. So 4 squared is 16. G of negative 2, which would be 2 times negative 2 minus 1. So 2 times negative 2 is negative 4. Minus 1 would be negative 5. And then it says to do h of 2, so 16, minus g of negative 2, so negative 5. So when we subtract a negative, remember it's the same as adding. So we'll make that big plus sign. 16 plus 5 would give us 21. There's 3 different ways to represent a function. We have a table, a graph, and a mapping. And so there's also another one, it's equation. So if we did the equation y equals 2x. The table, if you recall, would be, we would pick some x values. So let's do the ones that we're used to. If I do 2 times negative 2, I get negative 4. 2 times negative 1, I get negative 2. 0 times 2, I get 0. 2 times 1, 2. 2 times 2, 4. So I completed a table based on this equation, and then we're going to graph those points from our table. So we have negative 2, negative 4, negative 1, negative 2, 0, 0, 1, 2, and 2, 4. And we could connect those. We can see that that forms a line. Now the mapping is one that you haven't seen yet. We would put in our x values. Usually put those in numerical order. Same thing with our y's. And then we would just map them. So negative 2 goes to negative 4, negative 1 goes to negative 2, 0 to 0, 1 to 2, and 2 to 4. Pretty easy concept there. Alright, so on determining whether a relation is a function. For a table, a set of ordered pairs, or a mapping, does each input have only one output? So that's what you're asking yourself. So for instance, in the table, if this were my table and I had these points, 3 goes to 2, 4 goes to 1, 3 goes to negative 2. Since 3 goes to 2 and then turns around and goes to negative 2, that would not be a function. For a graph, we're going to do what's called a vertical line test. If no vertical line can be drawn that will intersect the graph more than once, then the graph is a function. If the vertical line intersects the graph at least twice, then the graph is not a function. So this works because when we draw a vertical line, we are testing inputs, and each time it hits the graph, that is representing an output. So if it hits the graph more than once, that means it has more than one output for that input. Let's take a look at example 2 where we're determining whether the relations are functions. So for each of these, since we're not looking at graphs, we're going to be looking at each input to see if it has only one output. Take a look at example A. We see a repeat in the inputs for 2, where first 2 is being mapped to 6, and then 2 is being mapped to 4. Since 2 has 2 different outputs, this would be not a function. On example B, notice that each one of our inputs, our x values, goes to only one y value. If, for instance, we had an arrow coming off of 2 that looked like this, where 2 was going to 2 different outputs, this would not be a function. But since that is not the case, this is a function. In example C, we're looking at each input. Negative 2 goes to 4, 1 goes to 5, 3 goes to 6, 5 goes to 8, and 7 goes to 10. So no input has more than one output. So this would be a function. Okay, our last example talks about graphing, and so we're going to look at the vertical line test for each one. So imagine yourself drawing vertical lines through each one of these. If any vertical line would touch the graph more than one time, it would not be a function. So here we can see that each one of these vertical lines is only touching that graph one time. So this passes our vertical line test. So yes, this would be a function. However, on number 2, or example B, when we draw this vertical line, we can see that it's touching at 2 different places, which means that for the input 4, we have 2 different outputs, 4 and negative 3.5. So this would not be a function. And on example C, if you draw a vertical line through each point that's given, no vertical line is going to touch more than one point, so it would be a function.